Hey geometry students, we're taking a look today at section 10.4, perimeters and areas of similar figures. You can use ratios to compare perimeters and areas of similar figures. Okay, so it's kind of neat because if the scale factor of two similar figures is the ratio A over B, then the ratio of the perimeters is also A over B. And the reasoning there is that this is a length, just like the scale factor is a length. But now here's the really cool part. Then the ratio of the areas, and you know area is always squared, is A squared over the B squared. And I'm sure you guys can guess what would the ratio of volumes be. A to the third over B to the third. So it's kind of neat because you can figure out how volumes compare, areas compare, or perimeters. Having only one ratio, you can go backwards and forwards to figure out the others. So let's take a look at an example. Sorry, I'm still working with figuring this out here. Two similar polygons have corresponding sides in the ratio of 5 to 7. What is the ratio, larger to smaller, of their perimeters? Go ahead and write what you think that would be. Hopefully you said 7 to 5. First of all, it said larger to smaller. And their perimeter ratio, as we said above, is the same as their scale factor. Okay. So the scale factor we got when we talked about sides. Just notice this is lengths. This is how you can kind of keep this all straight. Lengths. But now we're going to jump to a different area here and say, what's the ratio of the larger to smaller of their areas? Well, as you can see right above here, that's a ratio, but you have to square each of them individually. So now I'm going to have 7 squared to 5 squared, which is 49 to 25. And that would be your answer. Okay? Now let's look at example 2. The scale factor of two similar parallelograms is 3 to 4. So as soon as you see scale factor, you think lengths. Okay, great. I got the lengths ratio. The area of the larger parallelogram is 96. What is the area of the smaller one? Okay, so we're going to do a proportion here to solve this. But I can't do this. So this is obviously the smaller parallelogram. This is the larger one. And they give us the area of the larger one is 96. And they ask us for the area of the smaller one. But that's not a true proportion there. Because I've got lengths here and I've got areas here. So to make this true, I need to go in here and make these areas as well. At that point, we can now just cross multiply and solve. So you're going to have the 9 over 16 equals the x over 96. Cross multiply, divide, and you're going to get 54 inches squared. All right, and the next one, the scale factor of the dimensions of two smaller pieces of window glass is 3 to 5. Again, lengths, scale factor. The smaller piece costs $2.50. So whenever you see a price like that, you need to understand that that's representing an area. Okay, for window glass, that's an area. So how much should the larger piece cost? Well, we need to get this length dimension into area. So we're going to square both of them and get 9 over 25. And finish the other half of our proportion. So the smaller piece is $2.50. So would that go on the top or the bottom? Very good, the top. Cross multiply, divide, and you should get an answer of $6.94. Lastly, this one gets a little bit tricky, but still really not too bad. The area of two similar rectangles are 1875. And I didn't see the rest of it, and 135. Okay, so they give us the area. I'm going to go over here because I'm going to need a little more room for this one. So there's my ratio of their areas. Okay, what is the ratio of their perimeters? So if this is the areas, and we said the ratio of areas was a squared over b squared, and we want the ratio of their perimeters, what are we going to need to do? That's right. I'm assuming you're all answering me. Take the square root of both sides. So when you go down here to take the square root of both sides, the length ratios, or the perimeters, are going to be the square root of 1875 over the square root of 135. Now, granted, it doesn't clarify how to do this, so you could divide those out, but let's just assume that they want it to be left in exact. Oops, sorry, I'm off the screen here. So let's break each of these down and see what we come up with. We'll break that down, and we're going to break that one down. So 1875, I kind of worked this out a little bit ahead of time. So 75 and 25 are the two. Square root of that is 5. This goes down again, square root of 25, square root of 3. It's 5. So 5 times 5 times square root of 3 is 25 square root of 3 on the top. That's for this one. Now I got to do the bottom. Square root of 135 breaks down into square root of 9, square root of 15. That is 3. Square root of 15. Okay, so we're going to put that there. Now, can we have a square root in the bottom, boys? No, that's not proper form. So we're going to multiply the top and the bottom by root 15, and we are going to get 25 square root of 45 over 3, and square root of 15 times square root of 15, remember the reason we did this was to get rid of that square root, so we're going to get 15 back times the 3 is 45. Now, hopefully you guys can see there's a couple other things that we can do here. Number one is the square root of 45 breaks down. So let's go up here. Square root of 9, square root of 5, 3 root 5. So now what do we have here? We have 3 times 25 is 75, root 5 over 45. All we have left now is to simplify these two. Okay, and if you divide them both by 15, you will get for an answer. Now tell me, boys, who would want to take the easy way out and simply divide those? That's not nearly as much fun as going through and doing the square roots and reducing it all down to this lovely number. So hopefully I didn't make any errors there. And you guys may find them. I should offer an extra point here if you guys catch my errors and send me an email. Actually, I think I will. If you catch me making any errors, send me an email, but you can't tell any of the other kids, the other boys. So that's it, guys. That's our 10-4, and I hope that helps you in completing your homework. Take care. God bless.